So this is an inverse of trig functions. So what we're going to talk about this for is, how to how to find the inverse or defining the inverse of all the trig functions themselves. Okay. So when it comes to this, when it comes to inverses, you can think of just swapping places. So essentially, a quick little definition of inverse is the concept of swapping the domain and range. So it's literally just going the opposite order, right? So if I go from function, call this f from a to b, right? I plug in numbers in for f, I get numbers out for b. It's just going the opposite direction. So if I start here, how did it get from the begin with? So this is, f inverse of x. When it comes to it, that's called the inverse, just going the opposite direction. And that's what we're going to define in here. Okay, so it's when it comes to, we're going to talk about, first we talk about sine. So when it comes to sine, we have y equals sine inverse. So this is not a negative 1 power, right? It's just defined to be the inverse of it. Okay, so it's not negative 1 power. So sine inverse means, and if I swap places, x equals sine of y. That's how we're going to define our sine or our inverse functions like that. Okay, so where everything is now flipped, right? So for example, the range of sine is from 1 to negative 1 because it bounds between 1 and negative 1, and the domain is all real numbers. Now this changes dramatically when it comes to that. So now where the domain is bound between negative 1 and 1, and the range is actually between negative pi over 2 and positive pi over 2. So this is the range, and this is the domain. Now in our case, we're always going to be talking about the range for our case. Domain we do care about, but when it comes to these type of questions and going forward, the range is what we're going to be talking about the most, and how do we deal with that kind of concept as well. Okay. Okay. So that is sine itself, right? So that's just sine of x, and we're just going to go through all of them as well. Okay. So next one down the list is cosine. So cosine of x. So cosine of x, again, going inverse, so y equals cosine inverse of x. And it's going to follow the same template when it comes to it. So this is mean, so I can rewrite this as x equaling cosine of y. Okay. And the same concept comes into play, right? We just go the opposite orders. So where domain is still between negative 1 and 1, but the range, however, is between 0 and pi. So knowing the ranges is going to be very important throughout this entire chapter. Okay, so that's cosine itself. Okay. So next up we go through the other ones. The next one is tangent. Okay. So again, y equals tan inverse of x. This means, so I can just rewrite this as x equals tangent of y. Okay. Where the domain is all real numbers. Okay. However, the range is bound between negative pi over 2 and positive pi over 2. So very similar to the sine. The only difference is not included in it. That's the only major difference between tangent and regular and sine, right? This one's including the two endpoints. This is not including the endpoints. So when it comes to it, okay. All right. Next up, we have Cosecant. So this is again. Oops, sorry. Same concept. And again, right, the most important thing is figuring out the domain. So domain range. Now these ones are actually a little tricky. Domain here is actually the same. Negative 1 to 1. Okay. Oh no, actually, I'm very sorry. It's the absolute value of x has to be greater or equal to 1. Believe it or not. So it actually has to be smaller than -1 and bigger than -1. So it goes the opposite orders when it comes to it. Now, when it comes to the range, however, it is identically to the sine function, except y cannot equal 0. That's the only exclusion. So very similar. So notice, sine inverse is, almost exactly as the other ones when it comes to ranges, right? This is exactly like this one. The only difference is y cannot equal 0 because, secant is 1 over sine. So, you can't have 0 at the bottom. That's the only, criteria when it comes to that. All right, so let's finish up and do the other ones as well. Okay. All right, so cotangent. Okay. So since this is the opposite of a tangent, right, you flip them. It does have the exact same domain. It is all real numbers essentially, just everywhere. And for the range, it's actually corresponding to the cosine. So remember, that's the cosine portion. Again, the only difference is not including 0 and pi. So it's strictly between 0 and pi for cotangent range. And then the last one is secant. Very similar as to cosecant. So it has to be bigger or less than 1. So it's not bounded between them. And believe it or not, it has almost the same exact range as well. So this is exactly just like the cosine, right? So, which makes sense, is 1 over cosine. Again, the only difference is because it's 1 over cosine, y cannot equal 0. Those are our domains. Okay. So that's essentially 7.1 there. Okay. So the next part of 7.1 is just, using this type of stuff. So what I mean by using this type of stuff is, well, what if we now want to, evaluate a couple things? So let's find um, the exact value. And we'll do a couple so you can see what's going on here. Okay. So let's say we want to find the exact value of sine of sine inverse of, let's say, -1/2. Okay. So what we want to do is just we're going to make this equal to theta. So we're just going to set it equal to theta. And now we're going to follow the exact same template that we have here to go backwards, right? So here we have this situation as an example. We want to convert it to its other form. That way we can actually find the sine of it, okay? Now remember, x is being evaluated, so it's going to be x equals sine of y. So in this case, it's going to be -1/2 is equal to sine of theta, okay? Well, now it's not that bad to figure out, right? Now we just got to figure out, when is sine theta equal to -1/2? And there should be, well, two ways, right? There's a couple of ways to go around the unit circle. So let me just pop up the unit circle so you can see where that would be about. Here we go. Okay, and we just look, right? So we want sine theta to be -1/2. So we have going around. So remember, sine is the y value, so none of these are negative over here, so it's right here. So we have it at 7 pi over 6. That's one of them. And the other one we have at 11 pi over 6. So we have two options. So, but we have a problem, right? Because what was the range of sine inverse, right? So the range of sine inverse was bound between -pi/2 and +pi/2. So what you kind of want to do is, if I draw the unit circle, the only numbers I can choose from is bounded between here. So from here to here, meaning none of these numbers actually exist in sine inverse, right, when it comes to it. So what we want to do is, well, so this one doesn't exist because it's over here, so we can't actually use that. But this one goes down here, right? This is 11 pi over 6. But the thing is, it's not 11 pi over 6 because we're not going over the entire unit circle, right? Again, assuming that this doesn't exist, we're stopping here and starting all over again when it comes to it. So we have to write another way to write 11 pi over 6. Well, since this is theta, right, and theta goes this way, well, that makes it positive. So if we go the opposite direction, going, counterclockwise, that automatically makes it negative when it comes to it. And now, what's the equivalent of 11 pi over 6 is negative pi over 6, because that's actually what's left over to get to the old, center itself. So believe it or not, this actually is negative pi over 6 because of that. Okay? So the whole concept of these kind of questions is, okay, we want to figure out where that is, and then from there, can we figure out which one is actually in the range of it, and then go from there when it comes to, now it's never going to be that exact value, so we have to influence it, right? Because remember, 11 pi over 6 means we're going the entire unit circle, but you can't go the entire unit circle, half of it doesn't exist, right? There's nothing there, so you're just stuck here and you can't go all the way around. So you have to find an equivalence of it itself, right? Because we can keep going around the whole unit circle, right? I can go down here, or breaking down here. So for instance, if I go to my unit circle, if I'm looking at the sine inverse range, 7 pi over 4 is equivalent as negative pi over 4, right? Because that's what's left over to get to the whole center of itself, right? I can do the same thing here. 5 pi over 3 is equivalent to negative pi over 3. Hopefully that makes sense when it comes to it. Okay? So that's kind of what we want to do when it comes to it. So we got to, and that's the reason why, if you notice, right, I did not put this as 3 pi over 2. I put this as negative pi over 2 because, again, right, 3 pi over 2 is equivalent as negative pi over 2, right? So you're starting from here and going all the way up there. So that's the reason why the ranges are a little tricky when it comes to it. Okay, so let's just try one more so you guys can see how that will work out. Okay, so let's suppose we want to do, let's say, cosine inverse of, what's a good one? Let's say negative 1/2 as well. Okay, so we'll just do the same thing. Make this equal to theta. So if we convert this, is now negative 1/2 is equal to cosine theta. Okay, and now all we do is the same exact thing. Go to our unit circle, and we got to figure when is cosine equal to negative 1/2. So again, remember cosine is the x value, so it's right here. So it's 2 pi over 3. That's the one of them, and the other one is down here. So 4 pi over 3. Okay. So now we go back to our portion, and again, going back to our units or our ranges, cosine is bounded between 0 and pi. So if we make the circle again, so we make the circle again, we go from 0 to pi. So meaning this does not exist. Okay, so since it does not exist, 4 pi over 3 is down here, so that doesn't work. However, 2 pi over 3 is here. So it does exist in this portion. So there's only one answer, and that answer is 2 pi over 3. There we go. Okay. So here's the problem though. What if we did not know what it was? Right? So for instance, what if, well, we'll talk about that in a little bit, but that's essentially what section 7.1 is all about. It's just converting and seeing which one's in the actual range of it, and just going from there.